Alright class, we're here in Mr. Dady's physics class, and we're going to be doing an experiment today, and we're going to be talking about Newton's 3 laws, and all the 3 laws apply to forces, and you'll find any of the 3 laws us playing tennis, and we're going to play a little bit of tennis, and then we're going to go inside and explain the laws. Ready? Oh God! Hello class, we're here in physics, and we just did our experiment outside with us playing tennis, and we're going to talk about Newton's first law, and that first law is anything in motion stays in motion, or anything at rest stays at rest unless acted upon by unbalanced force. And when we were playing tennis, and when the ball was in my hand, the ball was balanced, and then when I hit the ball, it was balanced when I hit it, but when the ball was in the air, it was unbalanced, and it was unbalanced going to him because it was decelerating. But when he hit the ball back to me, when he hit it, the moment he hit it, it was balanced. And then when it was traveling back to me, it was unbalanced. And we played tennis, we had a lot of fun, and that's Newton's first law.
Newton's second law is force equals mass times acceleration. So mass and acceleration are indirectly proportional, and force is directly proportional to mass and acceleration.
Alright, so I'm going to talk about indirectly and directly. So you can't really change your mass or your swing. So if you want to increase the acceleration, or if you want to increase the force, you have to increase your acceleration.
Basically, if you want to keep the same force, but you can't increase your mass or acceleration without increasing force, you would decrease your mass to increase your acceleration, or the other way around, to keep the same force in your swing. That includes examples of bringing a different tennis racket or hitting harder, or bringing a bigger tennis racket and hitting not as hard. Newton's third law is every action has an equal or opposite reaction. As we see with this equation, they both, due to Newton's third law, have to have the same force. With that force, that means that since the racket has more mass, it has less acceleration. And since the ball has less mass, it has more acceleration. Due to that difference in mass and acceleration, since the ball has less mass, it would be pushed off and go towards your opponent. With our free body diagram here, we can see when we hit the ball, we push it with 190 newtons of force. Of course, with air resistance, we're going to have to apply the 10 newtons of force that a ball will be applied. We also have to take in the fact of normal force and the force of gravity, keeping it from dropping through the floor, basically.